In this chapter, we will be reviewing and introducing some ideas in statistics. In this lesson, we'll be looking at standard deviation.
Okay, hi everybody. So in this lesson we're going to introduce this idea of a standard deviation. Now I referred to it in a previous lesson when we were looking at what the calculator can do and can calculate. Now we're going to talk about it in a little bit more detail here. Before we get to that though, what we're going to do here is we're going to take a look at a bit of data here. So to start off with here, what we've got here are the temperatures, let's say the average temperature per month for Victoria and Ottawa, okay, going from January out to December here. And so now what we're going to do here, and I've already got this entered into my calculator, so what I'm going to do is I'm going to just calculate the mean and median for each set of data here. So for Victoria, when I do that, I am going to get a mean is going to be 9.5, and I get that my median is 9. Okay? I'm going to do the same thing, just like we did before. I'm going to use the calculator to do it. All the data has been entered in, and when I do that, I get a mean for Ottawa of 9.5 and a median of 9. Okay. Well, that's interesting because the mean and the medians are exactly the same. But if you take a look at the data here, it is different. Take a look at Ottawa here. Ottawa goes down to get a low of -4 up to a maximum of 23. Victoria never does that. So just looking at the measures of central tendency, the measures of central tendency aren't giving us enough information to really distinguish between the two of them. The issue here has to deal with what we call the dispersal of the data. Okay, how it's being spread out around the mean. Okay, and actually if you take a quick look at the graphs here, you see something quite different here. So notice that for Ottawa, the temperature goes lower and it goes up higher. Okay, it's a little bit more gets pulled in here, whereas for Victoria, the temperatures are a lot more evenly spaced out here, okay? It doesn't go quite as high, doesn't go quite as low. Everything's kind of stretched out here. It's almost like, if you think of this as like a bit of clay here, it's almost like for Ottawa, it's been pinched in, and Victoria's been squished down a little bit, okay? So clearly, the measures of central tendency aren't enough to give us an idea of what's different between these two sets of data here. So we talk about measures of dispersion, how much the data is spread out here. Now, there are two that we're going to use here. You've already seen one, okay, from previous courses called the range here. Now, we're going to do it just a little bit differently here. For Victoria, if you think back to the way range works, you might go back up to your data here. Victoria goes between, what have we got here, 3 and 18. So on one hand, you might say that the temperature of Victoria is going to be from 3 out to 18. While at the same time, you might say that the range for Ottawa is going to go from -4 up to 23. Okay, so -4 out to 23. But we do things just a little bit differently. I mean, it's totally related to this, but it's a little bit differently here. The range of temperatures for Victoria is actually going to be the difference between the max and the min. So your range is going to equal your max minus your min. Okay, max minus the min. So 18 minus 3, 15 degrees. What we're trying to say here is there's a 15-degree spread from the low to the high end of the temperatures here. The range for Ottawa is going to be the low minus the minimum here. The maximum minus the minimum. So 23 minus -4. So 27 degrees. So we see that there's a much larger spread in the data for Ottawa. Now, that's good. That gives us a little bit more information, but it's only using, like it says down here, it's only using 2 bits of information from the data sets that we've got here, just the lowest and the highest. So that still doesn't give us a really good idea, which is why we introduce this idea of a standard deviation. Okay, it's the measure of the variation or spread between the data values and the mean. Okay, now I know that in a lot of cases what you're reading there, it was a lot of mathematical blah, 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 blah. So standard deviation is the measure of yeah, whatever. Okay, but let's get a little bit more specific. What does it mean here? Well, a small standard deviation means most of the data is close to the mean. In other words, it's pinched in. So if here's your mean, right down the middle, most of the data is right close to the mean. There's a bit of a spike. A large standard deviation means the data is spread out from the mean. So if here's the mean, the data looks more like this, right? It's a, whoops, sorry, you can't see that really. It's a little bit more spread out. We're not seeing that same peak at the center there. That's basically it, okay? So small standard deviation looks like this, large standard deviation looks like this. Now, until we actually start doing some calculations, it's hard to know what is a large standard deviation, what is a big standard deviation. A lot of times that has to do with the data values themselves that you're working with here. Let's zoom in a little bit here. So, whoops, sorry, wrong direction. So you can see this. The standard deviation of a population, we use the Greek letter sigma for that. If it's a sample, then we just use the letter S, okay? But here in Math 20-2, so for this particular course right here, we're going to assume that the data comes from a population. So we're typically going to use the mu for the mean and the sigma for standard deviation. That'll just kind of be our standard for this particular course as we're getting introduced to these particular topics here. Okay, so now I'm going to show you how we can use the calculator to find these standard deviation calculations. Okay, so let's take a look at this question here. It says the heights of the basketball team are given in inches in the list below here. So we're going to enter this into the calculator. I'm going to see if I can make sure that we can see everything here. So I will go stat, edit, and I've cleaned up the list, so we're good here. I'll just enter this in. So 70, 72, 79, 71, again 72, 81, 80, 68, 66, 76, 67, and 75. Okay, and 12 looks like the right number there, so that looks good here. So now I'm going to quit. We'll go back into stat here. Calc, and again, this is just one variable statistics here. There is no frequency list, so I'm going to leave that blank. Hit calculate. Whoops. What did I do? Oh, I'm sorry. I must have, let me clear that off here. I didn't even take a quick look at that. Yeah, sorry, it was list 2. I needed it to be list 1. My mistake. There we go. Okay. So the question is asking us to determine the mean and the median to start off with here. So the mean, and we're going to use just this one up here. The calculator has a little bit of a difficult time with the mu right there, so they just use the X bar. So it looks like the mean height here is going to be 73.1 inches. The median, I'm going to use my down arrow, the median is 72. Okay, now let's keep going. We got a couple other questions based on this same one here. The little arrow, if you're interested here, the little arrow is just pointing to a screenshot of that, the calculator here. Let's keep going here. So the screen also tells us the standard deviation. So we're going to look at the standard deviation. It's going to be right there. Okay, sigma x here, and that's going to be 4.9. Okay, so the standard deviation to the nearest tenth of the heights of the basketball team is 4.9 inches. Now, let me just kind of try to explain this really quickly here. So what this means here, and I'm going to try to give you a bit of a visual of this. Here's our mean here, and we already know that our mean is 73.1 inches. And then the data kind of does this, goes up, does this, and comes down. Now, to get a sense of what we mean by the standard deviation, look at the curve here. See how the curve kind of curves up? And then you hit a point where the curve starts to curve down again. So it's changing direction. This one is swooping up. Then we hit this little point here where the graph starts to swoop down. Now, that's the same on both sides because the graph should be symmetric. This distance right here is roughly the standard deviation. I mean, that gives you a pretty good idea of what the standard deviation is, what the spread is. What the standard deviation is it's the average distance that everybody is from the mean. So if all these basketball players are in the room and all of a sudden we know the average height of everybody, And everyone starts saying, well, I'm 5 above, well, I'm 2 below, I'm 3 below, I'm 7 above, sort of thing. And they added up all of those differences and found the average. That would be the standard deviation. Okay, graphically it gives you this little, it looks a lot like that right there. Okay, so that's what a standard deviation is, or at least I hope that gives you a bit more of an idea, a little bit of clarity on it. Okay, we're letting the calculator do clearly most of the work here. Now let's take a look at number 3 here. There's been a miracle growth discovery. Each player grows 3 inches in the next year. What would happen to the mean height? Well, if everybody gets bigger by 3 inches, just think about how the mean is calculated. You just add up all those numbers and divide by the total number of numbers. Well, the total number of basketball players has stayed the same, but each one of their heights is going to go bigger by 3. Well, basically what that's going to do is this is going to increase, okay, this is going to increase the mean by 3. Everybody, basically that means this. So here's your graph here. Goes up like this. Essentially what's going to happen is this whole thing is just going to shift this way. Same graph, same distribution. Okay, a guy that was shorter than average is still going to be shorter than average, just that average has now been moved up. Now, what would happen to the standard deviation? Well, if you take a quick look at this, because this graph here gives you a pretty good visual of that. Remember that the standard deviation is the distance from there to the mean, there to the mean here. So now, granted, my graph is a little gross here. It should be a lot prettier. But that distance really hasn't changed. The whole graph has just slid forward. So what would happen to the standard deviation? It would stay the same. Sorry, it should be stays the same. Okay, the mean is going to increase by 3. The standard deviation won't. Okay. So the next 3 questions here that we're going to work with this chart right here. This is below is a chart of the revenue for Average Jane's, a restaurant chain here. So you're seeing the state and the city, and then for each of these years you're seeing the revenue. Okay, which I'm hoping is more than just like $5,000. Hoping that that's a scaled up thing. But anyway, doesn't matter. It's just the information that we need here. Now, one of the things that we're going to have to do here is pay attention to what the question is asking. Because when you first glance at this, you might be tempted to like enter all of this data into the calculator and have it just calculate the mean and the standard deviation here. But actually, you got to really pay attention to what what the question is asking specifically for. So, for example, this first one here says calculate the mean revenue and standard deviation for Average Jane's in 2006. Okay, that is just this data right there. So now I have entered that into the calculator already. Okay, that is in my list 1. So now to get that, I would press Stat over in my calc, and I just want list 1. Okay, and so our mean is going to be $3,266.35, and our standard deviation from that will be $1,866.92. That's a pretty large. Whoops. That's a pretty large standard deviation there. Okay, so there's a huge spread in the data here, and actually you can see it when you look at this. We go from 5,000, just a little under 6,000, to what was the small one here? I think it's like $900 there. So yeah, there's a bit of a swing in the data. The next question says, calculate the mean revenue and standard deviation in Vail, Colorado from 2006 to 2009. Well, that is just this data right here. Okay, that's just those bits of information along here. Now I've got that in list 2. So now let's go through stat, calc, 1 variable statistics. This time I'm going to turn this to list 2. Okay. And we get here, whoops, we'll put this down here, that our mean is, what is that? $2,143.98. And our standard deviation, now look at that. Our standard deviation is $24.02, which means this data here is way, way tighter to the mean. There's very little fluctuation here. And take a look at that data there. That is actually the case here. 2100, 2100, 2100, 2100. There's a very small dispersion in the data there. Wonderful. And now it's hard to see with my blue here, so I'll use red for this one. Calculate the mean, and standard deviation in California from 2006 to 2009. Okay, California, so I got to look at the state here. So here we go. So that means that is going to be all of this data down here. And that, just like before, I have already entered into the calculator. So again, stat, calc. This time it's in list 3, so I'll press second 3, enter, enter, enter on calculate. Okay, and so now I see that my mean, and this is the mean for California, is going to be $2,861.78. And our standard deviation, now our standard deviation is again quite large, $2,096.67. Which means that I've got some data values here that are quite high and quite low, okay? And when you take a look at your data, you do see that. In fact, you see like there's the 6,000 here roughly, and then here's the 900, here's 800, a little over 800. There's a few of those, and there's a few big ones here. So it's really the difference between San Diego and Los Angeles that's causing that, or the values in there that are causing that swing. Anyway, I hope that makes sense. And now we're gonna go back and introduce that idea of a frequency table again, and I'll show you how it works with standard deviation. Okay, so now let's take a quick look at what happens when the data is given to you in terms of a frequency table. And as it turns out, there's not much different. In fact, there's basically no difference between how you would handle this and what we did in the previous lesson here. So the frequency table to the right shows the marked distribution for a trig quiz here. So we're going to get the mean score and the standard deviation for the trig quiz. Now, first thing we got to do is enter this in, and notice that this is now going to be a case where we've got the list 1 and the list 2. The data is just the score. Okay, this isn't giving us different data. This is just telling us how many times these scores were had by students here. So stat, edit, and it'll be 3, 4, 5, 6, 7, 8, 9, 10. And we'll come over, and that's going to be, what is it, 2, 5, 7, 10, 11, 9, 4, 3. And again, I like the fact that I ended up at the same row as my previous column there, so that's good. That's good. So we'll quit. Stat, calc. This is still one variable statistics, except now I'm looking at list 1, and this time here my frequency list is list 2 here. Calculate, and there we go. And there's our data here. And what do we see here? Well, we see that the mean is going to be 6.6, okay, out of 10. And the standard deviation here is going to be 1.8, okay, or 1.76 there, 1.8. So that's pretty good, okay? That means that there's a 2-mark swing there, okay, so roughly 2-mark swing here, but that's a kind of a nice tight little standard deviation here. Now let's take a look at the next question here because they are related. It says Marcus wrote the trigonometry quiz late and got 3 out of 10. How will his mark affect the mean and the standard deviation? Now I want to think about that. Okay, so think about where the mean is located here. 6.6, and we're going to add a mark to it that's smaller than the mean. And like substantially smaller. That's less than half of that. So remember what I said in a previous lesson, that the mean is sensitive to outliers. When there's a data value that's not close, it tends to have an effect on the mean here. So I suspect what this is going to do is this is going to lower the mean. Now we're going to double check this in just a second, and I'll show you how that works with the chart here. This is going to lower the mean. Now, additionally, what is that going to do to the standard deviation? Well, now what's going on here is we're throwing a mark in there that's kind of on the low end. So think about what the data looks like up here. Okay, I should have done it this way. So here's my mean here at 6.6, and then we've got this standard deviation. Okay, that little width right here is, let's say, 1.8. 1.8. Now what we're going to do here is we're going to take that, So we've got that, but we're going to, I'll just draw that curve in there. We're going to add another mark up here. So what we're going to do is we're going to actually put a little bump here, if you will, because we're going to add a little bit more data over here, and that's going to cause the spread of the data to change a little bit here, okay? To smooth out that little bump there, this curve is going to have to get slightly larger. Okay, it's going to drop down a little bit, going to have to get slightly wider here. So I suspect what's going to happen here is it's going to increase the standard deviation. And I'll just use the little symbol there. I think it's going to increase the standard deviation. Now, we can check that fairly easily because if we go back into the data here, so stat, edit, we're just saying that Marcus wrote late here. So what's going to happen here is the number of quizzes that had a mark of 3 is going to go up by 1. So we're going to change that 2 to a 3. Now I'm going to quit and I'm going to do the same thing, the same calculation again. So one variable statistics, and it's already set up to do that calculation on list 1 using list 2 as the frequency. Now let's take a quick look. What did it do? So 6.6 was my average, 6.5 is my new average, so it did lower the mean. Okay? 1.8 was my standard deviation, 1.81. Now, I don't remember. I don't remember if that went up or whatever. I'm going to have to go back. Let's go back. So this is 1.81. Okay, so now we've got this 1.81. I'll go to the nearest hundredth because I'm not seeing it clearly enough here. Now I got to go back and double check that because I didn't pay close enough attention. So that was 2, quit, stat, calc. Okay, yeah, there we go. So this was 1.76. Would have been better if I had written it like that, 1.76, and this did go up to 1.81, so it did increase. Okay, let's take a look at this next question. It says the frequency table below shows the number of hits per game by a baseball player during the course of 1 month. So we're supposed to calculate the mean and the standard deviation to the nearest tenth. Okay, so here's our data. It's just a matter of separating out, making sure we're clear on where the data is and what the frequency is, and here it's labeled nicely what the frequency is. So stat, edit. I've got data in there from a previous question, so I'm just going to go up to the label there, press clear and enter, up, clear and enter. And now I'll enter the data in 0, 1, 2, 3, 4, and then the frequency 6, 11, 5, 2, 1. Okay, now that it's in there, it's just a matter of stat, calc, one variable statistics, and it's already set up for a frequency chart, so I go down to calculate, and then boom. So our mean is 1.2 to the nearest tenth, and our standard deviation is 1.0. Whoops, I'm just off to the side there a little bit. And there you go. There it is, as easy as that. Okay, now we're going to end with this question right here. It says, consider the following 2 histograms representing the class results on 2 math quizzes. So here's the radicals quiz, here's the quadratics quiz. And the first question says, without doing any statistical calculations, explain which quiz had the greater mean. Okay, the mean is the measure of central tendency. It's where the middle is. So when you take a look at this data right here, and I've got this little peak here, the mean looks to be right down that middle right there. This is where I suspect the mean is. Here, the mean is going to be again down the middle. So I've got 1, 2, 3, 4, 5, 6. So right down the middle. Now, the mean ends up being a score, okay, a value along the x-axis, and we measure that by how far over it is from the y-axis. Well, this mean is clearly further over along the x-axis, so this one has the larger value. This one here, the mean is 3.5. Here, this is 5.5. So which one has the greater mean? Well, that's the quadratics quiz. Now, which one has the greater standard deviation? Now remember, the standard deviation is a measure of the spread of the data. When the data is pinched in close to the mean, it's got a small standard deviation, and when it's more spread out, it's got a larger standard deviation. So this one right here, again, the quadratics quiz, okay, the quadratics quiz is clearly going to have the larger standard deviation. Now, we're supposed to confirm that that's true using the calculator. Okay, so here's what we're going to do here. We're going to enter in the values from these two charts here. So we'll start with the the radicals quiz. So stat, edit. I've got data in there, so let's just clear it out. And now my score, okay, is going to be along the x-axis. That's going to be 1, 2, 3, 4, 5, 6. And this time my frequency, well, I read the frequency off of the y-axis here, so that's 2, 4. Now that's halfway between, so let's assume that's got to be 9 there. 9 for 5, we're back down to 4, and 2 for 6. Okay, so now let's quit. We'll use our stat, calc, one variable statistics, list 1 with a frequency and list 2. Okay, so for the radicals, our mean we see is 3.5, and our standard deviation here is 1.3. Okay, when we round that to the nearest tenth. Now, the quadratics. Let's go back in to our data. And I still have to change my data here a little bit. I'll just delete, so 3 is the top one. And then I just need 7 and 8 down here. And then I'll go through and I'll just overwrite all of this. And in every case here, it's just 5. So that makes that really easy. Quit. Stat, over to my calc menu, one variable statistics. And here, okay, for my quadratics, we see that the mean is 5.5 and the standard deviation is 1.7. Okay, so 3.5 and 1.3, 5.5 and 1.7. Notice that both of those measures are larger with the quadratics than they are with the radicals.